My name is Sarah Kirn, that's K-I-R-N, and Sarah with an H, and I work for the Gulf of Maine Research Institute. And I have been the Vital Signs Program Manager since 2002. In the Vital Signs Program, if I can just keep going.
Yes.
The Vital Signs Program in 2002, it was, the idea was handheld technology seemed very appealing to children, so that seemed like a good tool for us to use to engage kids in something. And the idea of using handheld technology to collect data and then share it, and maybe even use, the original idea was to have kids using the same technology that that adults and scientists were all using, and looking at the same bodies of water and collecting information and sharing what they were seeing from their three different perspectives. And it evolved pretty quickly from that. When I started, we were using it to collect some water quality information. It was a Palm Pilot, and we had attachments for cameras and GPS receivers and some data probes that were custom connected for us that didn't ever work very well. So the things that kids were typically able to collect were location. They could use the picture to take photos, and get a location. The GPS receiver worked pretty well. And the teachers that we were working with in that pilot really wanted us to be using the data and wanted to know what they could tell their students about who was using this data. And there were kind of two things wrong at that moment. One, there was no real interesting use of the data that I could think of. And two, I don't think citizen science is about kids collecting data and giving it to somebody else to do something interesting with.
Yeah.
I think it's about kids being participants in the whole process of science, from asking questions and going out and doing exploration and collecting data and then thinking about what does that data mean and sharing what they found. But we got excited about the idea of invasive species because invasive species are things that you need to document with photographs to show that what you really saw. You need to have a location for where you were so somebody can get back to that location either to verify it or follow up or do some mitigation kind of effort. So we came back to the US after doing that project in Ireland, and the whole handheld market was in chaos. If you remember back in the old days that Palm Pilots were starting to incorporate cameras, which is great, but then phones were actually starting to incorporate Palm Pilot technology and cameras. And we couldn't think of any teacher who'd be willing to have 30 telephones, mobile phones in their classroom. So the handheld market was gone. But then in Maine, we have this fabulous one-to-one laptop initiative. Since 2003, every student in 7th and 8th grade has had their own laptop computer issued by the state through the Maine Learning Technology Initiative. So we thought, well, that's obvious. We need to use the web as our platform. And we need to create a program around invasive species. It was because we saw that as the opportunity because we knew there were scientists who were studying invasive species, and we knew we could help students be successful using technology to scaffold them and designing a learning experience for them. We knew we could help students be successful in collecting data that they could share and that would be of value to the scientists, whereby the scientists would be intrinsically motivated to participate, which was really important to us because we wanted their participation. So we wanted to make sure that there was a real partnership at the heart of this. So we sat down with a group of scientists and teachers, and I don't know, maybe 2006 or 7, maybe 2007, and started talking about invasive species as a topic, and what were the species specifically? What were in all the habitats in Maine? So we're looking at freshwater species, marine species, and upland species or land-based species. What were the species that were invasive that the scientists would actually trust kids to identify? That was important because we wanted to set them up to be successful. So we sat down with these scientists and teachers, and we came up with a list of species that were going to be appropriate. And then we came up with the other data that scientists needed in order to make sense of the observation of the species. And then talked with the teachers, well, what can you actually do in a 45-minute class period? And we kind of brokered the content of vital signs, the data that was going to be collected with all of those partners right at the table. So another way that we've set the kids up to be successful is instead of having kids go outside and having to identify all the species in a given place, we ask them to join a field mission or pick a species that they're interested in, and they get information from the website, a one-page printable PDF of photographs, open source photographs, or not open source, but they're all Creative Commons licensed photographs, or increasingly they're photographs that participants have taken of species. Mm-hmm. We've updated our cards. So they print that, they go outside, and then the task becomes, looking to see whether or not I'm seeing the species that I'm looking for. Is it here or not? Did I find it or not? And then backing up whichever claim I've made with evidence. So the emphasis is not on finding a species, because in our early testing, when that was true, kids would find whatever we asked them to look for because they wanted to be successful. So we changed it so that the emphasis was on the evidence that you're collecting to back up your claim. Mm-hmm. Because in science, it's really important. It's often just as important what you don't see as what you do see. And that's not an intuitive kind of point for kids. So the actual process of doing vital signs, you get one of these species cards, you go outside, you look to see whether you found it or not. You make a claim, I did find it or I didn't find it, and you back it up with evidence. So you can take up to 3 photographs and write 3 pieces of evidence. You can also write a field note. You can draw a picture, draw a sketch to illustrate either the place or a detail of what you're looking at. And you can take water quality information. You can do biodiversity counts, so how many different kinds of things did you have in a 1 meter by 1 meter square. You can do counts of individuals. So you collect that information onto paper, you put it into the computer, and you upload it onto our website. And you have to there's a peer review or peer quality check first. That's a simple checklist, and most students are working in teams, and they basically trade computers, each team, and then look at each other's work and do a quality check. And the team who's checking has to actually enter their name as part of the record. Mm-hmm. There's also a peer review that's a little bit beyond just the checklist. Did you do this, or did you not do this? It gets more into what's the quality of the evidence statements that you've made. Have you been very thorough and precise about your language and in describing things? Did you pick the right kind of the photographs that capture the most important characteristics of the species that you were looking at? So there's a lot of opportunity. I mean, in the evidence and in the critique, there's a lot of opportunity to work on critical thinking and reasoning. But anyway, the students publish that, and it gets immediately published publicly onto the website. It does not go through teachers' accounts first. And we thought that was really important, because if it was going to the teachers before it was going public, it would have a very different feeling for children who would be, you could publish any garbage because you knew your teacher was going to catch it and make you fix it later and help you fix it so that you'd look good out in the world. But if what I'm doing right now, I'm responsible for publishing my own work into this community that includes scientists and my peers and everyone, maybe I'm going to take a little bit more responsibility for it if I'm publishing it. So it goes straight out to the public. And then the public can comment. Anybody can create an account in Vital Signs and leave comments on work. When an observation is published, most of our species have a species expert associated with that species. And they're someone who's either doing research on that species, or maybe they work for the state of Maine and they're responsible for keeping that species out of Maine, or doing management work. So when a new observation of somebody who said, I went and looked for something, and either they found it or they didn't find it, when they looked for that species of interest, an email goes to the species expert associated with that species, and they get a link in their email that says somebody's made a new observation, you should go check it out. And they follow the link, and they can confirm or question the observation. Nice. And they have that instantaneous first pass data of what's being found, what's being looked for around the state. I think this is something that's interesting. In the K-12 education world in the U.S., and I'm going to just say the U.S. because I know it better than other countries, I think especially in kind of K-8, teachers' practice, general kind of everyday practice, is to find things that are interesting and useful and valuable and adapt them to work optimally for their students to meet their learning goals. So they're in the practice of going and taking things and remixing them and using them. They are not in the practice of sharing that out, but they are in the practice of kind of taking and adapting things. But so I think it's kind of the culture of K-12. And it's, I think with education, at least our philosophy here at GMRI, is we want education to be available to everyone. And GMRI specifically has a goal around providing universal access to all of our programs within our geographic area of focus, the Gulf of Maine. The Gulf of Maine bioregion, but Maine specifically. So we have a commitment to not charge for our programs and to make them as accessible to students in Portland, where we're based, as students in Aroostook County, which is parts of Aroostook County are farther away from Portland, Maine than New York City is. It's a big state. So that's our general philosophy. We want it to be open, and we want lots of participation, and we want a kind of diverse participation. And we wanted to make our activities available, and we expected that teachers would take them and do things with them. So we didn't, when we started thinking about vital signs and how we're going to develop it, we didn't know anything about Creative Commons. We didn't know anything about open educational resources. I think that phrase had maybe just been coined in about the same time. So when we got our first grant from the Hewlett Foundation, which was in 2007, I guess it was, 2007 or 8, then it made, they were very kind of encouraging of us using open source software and Creative Commons license, and it just made sense to us because we wanted this to be open to any student and teacher in the state of Maine. That's why we were looking at marine, freshwater, and upland environments, because we wanted any teacher and any students to be able to leave their school doors and be able to do an investigation, not just the kids who were lucky enough to go to schools that were close enough to walk to the ocean. And because we wanted it to be an authentic community, we wanted it to be open to the public and anybody to participate, because lifelong learning is a beautiful thing. And we wanted it to be open to any scientists and have the data free and available for them to download and use. So it just made sense. So a couple of the questions we asked teachers what the impact of vital signs was on their students, and above 75%, they could say yes to everything that they thought was true, and we had over 75% said yes to my students had a more authentic experience of science. Some of my students want to be scientists now. They were more interested and motivated to participate in science during vital signs, but also afterwards it persisted. They were more engaged in their schoolwork. So I think it's, and there's one teacher who I think of a lot, who was a wonderful teacher who'd been doing for 30 years. He'd been taking kids to a stream near the school and collecting water quality data. And he had this 30-year timeline of data, but he had no scientist who was interested in it, nothing to do with it. So he'd been going outside and doing something real with his students, but he hadn't had a community to contribute it to or participate in with. So he said that vital signs just reinvigorated him for teaching, and he's probably stayed a teacher now for a couple more years than he would have. So there's probably a few teachers who stayed teaching for an extra year, which I think is a huge victory. You think of the number of students impacted by having a really great science teacher. Yeah. And a bunch of scientists have gotten data that they wouldn't have gotten, and see citizen science as an opportunity and a partnership that they might not have made use of before.